The world needs renewable materials to work. Because the Earth is the ultimate closed system, we only have so much material to go around, and we cannot rely on fossil fuels and petroleum-generated materials forever. They're simply not going to be there. So renewable materials absolutely have to work, and FibreCITY is the best shot so far at actually trying to understand how we can make the best of the natural materials that we have. I joined the CIC, and one of the first things I was looking at was what was the landscape of research in natural materials and biocomposites. And it was very clear to me very quickly that a lot of what was being done out there was ad hoc. It wasn't particularly well organized, the research was patchy, and what we really needed was a central body to bring it all together and try and make some sense out of it.
That eureka point was just missing. If this was going to change, we needed to go back to science. We needed to go back to these materials and look at them in ways they had not previously been seen.
And that's really the germination of the idea of FibreCITY. The process is essentially starting from the field and ends up with the manufacturer.
In Canada, it would be a flax or hemp. In other parts of the world, it might be a canaf or a jute.
We go from the genetics of the variety right through to the final specifications of a given component. We monitor how those varieties grow from a GPS coordinate of where each individual stem is to exactly what weather it's experienced. So we have a very good picture of how these particular varieties were grown. We then take them through a very gentle decortication process, which is the technical term for removing fibers from the stem. We will then put them through several processing steps and put them into a matte form. The matte form then goes into a mold. It's infused with a resin system, and we go to the final component.
In many cases, in order to understand something, you almost need to see it. That's one of the reasons we have invested in different types of microscopy, so scanning electron microscope. And this gives us a high resolution. This allows us to see things that are 3 nanometers.
So that's when we start to look at the chemistry of the fibers. We look at the structure of the fibers down to the molecular level.
Being able to look at the surface, really being able to see its topography, what's going on, are these fibers clean, are they not clean, are they rough, are they smooth, how big are they, and what shape are they? FibreCITY is unique because it brings together equipment that has not necessarily been used on natural fibers before. Natural fibers have a microstructure. They actually have little crystalline elements called fibrils. And fibrils spiral around the fibers. So if you think of a spring that has a very small angle, it's very easy to pull. But as it straightens, it gets much stronger to pull. And if you've got something you're trying to improve tensile strength, that angle has a role to play. You can actually shoot X-rays at it and it'll cause a pattern. And based on that pattern that we get, we can sort of determine what kind of microstructure it has. We can then take that exact fiber and place it in a device that was originally designed for the hair industry. And then we can do the tensile strength of that material and break it. And we can say, this X-ray diffraction pattern yielded this tensile strength. Once we determine what's driving tensile strength, we can start actually building models to predict based on those properties. What we really want to see is a pooling of data. So each person that comes in and provides information to FibreCITY or advances FibreCITY knowledge, to bring that data together with other researchers who are also working with FibreCITY, and then being able to share that data to investigate information that they just wouldn't have access to.
FibreCITY is a platform technology, and it's really intended as a springboard into future endeavors. I'm basically miniaturizing that and operationalizing it so that someone can take FibreCITY out into a field and actually have his own FibreCITY right in his hand. Without understanding these materials, without being able to measure what we measure with FibreCITY, you can't manage it.
And that's where the real power of the microscopy could come in, being able to take the exact same fiber, finding a feature that's of interest, visualize it, see its chemistry, and then identify it.
And then once we have all that information in place, then we can make the best use of the resource that we actually have.
One of the best parts about composites is that you build them to meet your needs, you select your materials, you create your recipe. Natural fibers have a role. They are lighter, and if we can get the performance, they will fill a need in the composite industry.
There's tractor hoods that we've built. There's car components that we've built. Non-structural biomaterials are already prevalent in the automotive industry. We just want to take it to that next level. We need to give industry statistical assurance, like assurance they can rely on and believe. FibreCITY will be key to ensuring that people understand and believe that we can do that.
There's so much room for discovery in natural fibers, and not just in composite applications. Just fundamental understanding of how these materials perform, how they grow, how they change. The researcher opportunities are just profound, motivating, and exciting.
If you're interested in renewable content, if you're interested in your eco-footprint, if you're interested in lightweighting, if you're interested in materials that are probably more versatile than anything else you've ever seen, talk to us.